This will be part of my problem series. In this video, we will be analyzing a circuit with multiple resistors and one power supply. Once I am finished with this series of problems, I will be posting them in my stand store at this web address. Before proceeding, I want to explain the three web addresses that you will be directed to using. You have already seen the first here. This is a web address of my stand store, which will give you direct access to all of my electrical courses. On the last page, you will find an address that will direct you to obtaining the 50-page crib sheet and notes that will not only be handy when you're taking my courses in my stand store, but also for reference during any time during your career. Here you'll also be asked for your email address, which will not be shared with anybody or distributed in any way, but it will allow me to keep in touch with you and let you know of any additions or updates to my courses and or blogs. Near the end of the video, I'll be introducing you to a supplier of electrical products, which in my estimation are of value worth paying attention to. Let's do another quick example, this time using this circuit. We still have three loops for three loop currents, starting with I1, then I2, and then I3, but only one power supply this time. If you want, you can try and solve this problem on your own. So go ahead and pause the video while you try to calculate the currents I1, I2, and I3. When you are finished, start the video and see how I solved the problem. Writing the voltage law equations for each loop. For loop number 1, we get this equation, which expands to this and finally reduces to this equation. For loop number 2, the Kirchhoff voltage law equations look like this, which expands to this and finally reduces to this. For loop number 3, the equation is this, which expands to this and finally reduces to this. We now have three equations and three unknowns, and when we solve, we get this. I1 is equal to 6 amps, the current in loop 1. I2 equals 2 amps, which is the current in loop 2. And the current in loop 3 is I3 equal to 4 amps. In order to find the currents in the common resistors, it's a simple matter of summing the two current flows in each resistor. For the 5 ohm resistor, the current is I1 minus I2, which equals 4 amps. For the 40 ohm resistor, the current is I1 minus I3, which is equal to plus 2 amps. And finally, for the 10 ohm resistor, the current is I3 minus I2, which is equal to plus 2 amps. I want to introduce you to another product that's out there that is worthy of paying attention to. The 𝐃𝐈𝐒𝐂𝐋𝐀 solar generators are available in various capacities. Depending on the running and starting watts required, you can choose the right size of solar generator. For example, you can choose a small solar generator if you want to run laptops or cell phones, or perhaps a small freezer. On the other hand, a large solar generator would be ideal for extended power outages. To find out more about these battery generators and to keep up to date on any sales or discounts that are available, simply go to this web address. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.